The concept of lightning and sharing model is basically, yeah, the property of light actually, right? Lighting and shading, uh, with it depends on what type of lighting we have and what does the lightning property has. And when it comes to the shading part, which are there are many considerations which we need to go through when there is some shading happening, because the source of light, at what angle it is incidenting on the object, right? And uh, it also speaks about, is my particular ray of light falling on the normal of a plane, or it is falling on the just on the other side? Where should the shiny part be there? Okay, if it is the shiny part, what about the object? Is the object shining, having a shining surface, or it has a rough surface, or it has a irregular surface? Do we have any reflection of light on the object? Many of these considerations have to be taken, right? So, of course, lighting and shading has been taken from your model, from your Edward Angel textbook, chapter 6 and 6.1 to 6.4. So, properties of light. Okay, yeah, within this, we also learn about the lightning models, reflection models, normals, and color. So for now, you people know about, there we had light sources, and we have only 2 point sources which we saw in the particular slide from your other textbook, right? But we actually have uh, 4 to 5 types of light sources. One is the ambient light, so no identifiable source of direction. That means we don't have a source from where we actually get the light source, right? That means we are just getting the shower of light. For example, you have a cloudy weather in Bangalore. Can you identify where exactly the sun is? Do you know where exactly the sun is? Because it's very cloudy and we cannot even track where the light is. Best example for the ambient light. Best example for the ambient light is the cloud. I mean the where which is stopping the sun rays entering into the Earth's surface directly, right? So it is giving us, what do you call, a matte sort of light, right? So ambient light has that property. Ambient light has that property. The second one is point source. Best example is, we have a reading or a bulb, right? We can take it as a bulb. Bulb is a point source, right? Given only by point. Means at a single point, the light has been generated and it is moving towards the other sides. So that will be the ambient light. We also have, I mean, sorry, that will be the point source. And we have a distant light, okay, when we get a rays of sun, but we don't have any clouds between. If we have clouds, it becomes ambient light. When we do not have any cloud, then it becomes a distant light source. Correct? So last class we have spoken enough about the distant light source, and because in the light source, distant light source, the distance will be very like infinite, nearly, where the rays of light normally becomes parallel to each other. So spotlight is given only for that particular area only. We saw the spotlight in the last class with the cone like a structure which we saw that comes under the spotlight. So from source in direction, cutoff angle defines a cone of light. So in this cone of light, we have some issues. So what is that issue? We call it as an attenuation. The attenuation refers to some part of the uh, given area will be very bright, and again the rest will be less brighter. And again, uh, in other words, as we go away from the center of those spotlight, you can experience diminishing of light, or the brightness will come down. That's the best example for a spotlight. The light source described by a luminance. Luminance, as I said, separately, right? We saw, what was that? I'll show you. So here, as I said, we have a luminance in the sense we have many light sources. Each light sources will actually be individual to each other. So what we did, we created like a grid. So each box here is actually, each box actually is a light source. Okay, so each box is emitting its own radiation, I mean own rays, right, in all the angles, in all the angle. Basically, it is coinciding with many of the light sources here which we have. So each color is described separately. Each color means each light source will be described separately. Then in the light sources, uh, we have the intensity. Intensity, again, it depends upon the color, right? If I have more red light, more red intensity of light. Similarly, more with green, more with blue, it depends on that. Okay, where I stands for intensity, intensity of red, intensity of green, and intensity of blue is what the luminance or the brightness or the whatever the light source which we have. Sometimes calculate generically applying the RGB colors, right? And is about the first thing we speak about the ambient light, which we have with the common types of light. So ambient uh, light is having with the intensity is the same at all points. Is same at all points. Example for ambient light is the clouds are covered, right? So you people say whenever there is a dim light, you say the ambience is very good in this particular room, but still ambience here refers to where the intensity is the same at all the points. There is not much difference between the ambient light and a distant light source, but in the ambient light, usually it will be very dim, nearly. And when it comes to the distant light source, it will be, the rays will be parallel. That means the intensity will there be same, but it's of a bit higher than the ambient light. So this light does not have a direction, as I said, or it is the same at all the directions. So my intensity IA will be equal to intensity of ambient earth red, intensity with ambient of green, intensity with ambient of blue. So this is the formula for the intensity of ambient light. Next is about the point source. So remember, these are actually the values which you can actually see here, right? This particular note here speaks many things which are actually not present for what is necessary for you, and that is why we're just going across the simpler stuff, simple way of understanding, and later we can easily decode it. So ambient light is IAR, IAG, IAB. And with respect to the point source, the intensity of the point source is given by IP naught. It is a point source, and we actually write it in a form where IP naught or intensity of a point source will be equal to intensity of red in that point, intensity of green in that point, intensity of blue in that point. So intensity decreases with the square of distances. What do you mean by square of distances? Yeah, let's speak about that. As I said, I have a point source here. Let's assume it's a bright point source. Okay, so what are the properties of this? Okay, what is the property of it? Can I take this in particular? Okay, so the intensity of the light, I'll take a very light color. So the light rays will be falling on all the sides, let's assume. So let's assume this is the sides which it is moving. Okay. So it moves on the other side too. So this is what a point source. A point is over here and it is illuminating light on all the directions. That's what I said in the last class. If I have any object, let's say black is okay, white will be the better one. So I have an object here. So this object will be much more brighter here. This object will be much more brighter here in the sense this is very closer to that of very closer towards the point source, right? That's why it is looking pretty bright. If it is going away from the light source, obviously the intensity gradually decreases. The intensity gradually decreases. Furthermore, it will be much more darker. It will be much more darker. Now, anybody would like to tell me why does this happen? Why does this happen? And so later it will be a black color anyhow. The background is black itself. Yeah, why does this happen? No, you people who have studied physics and much more in engineering too. So here, as the distance between the object and this point source, if it is going more, that's what the equation says. If it is more, the intensity, if the denominator is going more, if denominator is growing more, the numerator, the overall value will be less, right? If the denominator is less, the overall value will increase, right? So P minus P naught, in the sense P is nothing but your object and P naught is the source of light, all right? So intensity from source to the object will be directly depending upon the square of its distance between the object and the light. So as you go away, the intensity of reaching this object will be very less. That's one way of understanding the point source. Next is one limitation of point sources. Yeah. So of course, when we speak about a small pin like structure, when we have a distant sun and we have a small object here, let's say a pin, the layers of light reaching that object doesn't make any sense because it is infinitely small. So the rays will overcome and we don't have any issues with it. But in case of an eclipse, what kind of eclipse? The lunar eclipse, or okay, we call it as a summer eclipse. Okay, so solar eclipse, I guess, where moon is in between the sun and the earth. So we have an eclipse. That means this moon is considerably, somewhat, can be relatable to the size of the sun, and over the distance, I cannot say that this distance is now infinite. This distance is now finite. Why? Because the object, it depends on the object which we are actually considering too. Right? As the objects, I say, grows bigger and bigger, the light rays which is moving from here, from this side to this side, and this side to the other side, they bend, right? And also the light source which is falling in this way creates a region which is called as the penumbra region. That means the shadow of this particular moon will be falling on this particular place. On where? On Earth. On where? On Earth. Right? So this will be your solar eclipse. So one limitation of a point source is you get variation with the intensity. Why? Because you have a dark black background which you have on center of the distance of, the center of the surface. On the other side, we don't have any issues. Okay, so over here we don't have any issues. Over here we don't have any issues. Distant light source, we have spoken much, given by the vector v. Intensity does not vary with distance. All distances are the same. That means infinite. Just example, sun ray towards the earth. Spotlight, most complex light source in OpenGL. Why? Because it's complex. Why? Because it is spot. It is, we have to provide it only for that particular space with some angle theta. Right? We also spoke about the attenuation problem which we have in this particular spotlight. So what do you mean by spot attenuation? Spot attenuation is nothing but you get on off sort of intensity. Why? Because my light source will be sent to one particular angle only, right? Whatever this light again, it will be moving in many directions. So sometimes it will be like bouncing on the surface and somewhere it will come out, right? So the place where it may come out depends on the rays which it is following. That's why it forms alternate rings. Alternate rings. That means here it will be bright, here it will be very bright, here it will be not bright. All right. So then again over here it will be very bright, and on the other side it will not be bright. So alternatively, dark and light particular sort of image will be occurred. So spotlight is brightest along IS with respect to the intensity of S with center vector V and phi from P to point on surface, intensity determined by cosine of phi corresponding to projection of V onto IS. So spotlight exponent E determines the rate. So I equal to cos E phi, which is equals to V dot intensity of spotlight over E. So for E equal to 1, we have this value. For E greater than 1, we have some curve narrows. So intensity bends. For any of these, okay, we have a particular example for that. Now we can think about how is reflected on a surface. Yes, this is a wonderful. This is basically what we had, what I had thought for today. Now we can think about how the incoming light is reflected by a surface. So if you have a very bright surface, very bright in the sense very shiny surface, what happens when you pass light on that? What happens when you pass light on a very bright surface? For example, a steel vessel. What happens when you pass a light on a steel vessel?
Light reflects, sir.
Light reflects. Why light reflects on whenever the ray of light falling on the steel vessel? What are the property here? What made light reflect when it falls on the steel surface, and why will the light will not reflect when it falls on wood, on floor, on cloth, on book? That's what I can see from here. Yeah, why doesn't it reflect? Why doesn't it reflect, guys? Don't know. It reflects because it is having a shininess on the object. Okay, the less the shininess, the less the dim. I mean, more the dim. More the shininess, less the dim. In other words, it will be very sharp and reflective surface. So when do you call it as a reflective surface? When light hits on opaque surface, some is absorbed, the rest is reflected. This can be transmitted to, but we don't want the reflected light to be falling on something else. First, the reflect light is what we see. The reflected light is what we see. So if you look into this diagram here, we have a surface, incident light, which is falling on a particular surface at each particular point, and from there the light gets reflected. Why? Because it is a curved surface. It is a curved surface, and this particular ray of light will pass through the camera or the viewer, and what we can say is this particular light rays can be captured by a viewer or a camera. The reflected light is what we see. Reflection is not simple and varies with material. The surface, microsurface define the detail of reflection. What I mean by the surface, microstructure define the detail of reflection. Here, my surface can be smooth or it can be having a rough surface. Okay, so what happens when the light falls on this particular thing here? It may not reflect in this way, it may reflect in this way, it may reflect in this way, it may reflect in this way. So not uniformly it will show on this particular direction, it may not show. All right, so it